All right, class, welcome back. I'm at an undisclosed location here, aka my shop, and we're going to talk about the octet rule today. So, as we've learned in the first quarter, atoms form molecules and compounds to achieve a kind of electrostatic stability, and this is by achieving, in most cases, an octet. In other words, 8 electrons on the outer sp valence electron shell, as in the case here if we had the electron configuration just of neon, which is element 10 on your periodic table. Notice that neon and all the noble gases except for helium end on the sp6 square. So when we take the case of magnesium, which is element 12, he has 2 electrons on the outer s orbital. So it is ergonomically more sensible for magnesium to lose these 2 electrons and mimic neon rather than gain 6 and mimic the next noble gas in the series, which is argon. Chlorine, on the other hand, starts off with being on the 5th square in the p orbital. In other words, he has 7 valence electrons, s2p5. So only one covalent or ionic bond needs to be made. So this is why magnesium chloride is MgCl2. Magnesium has 2 electrons to get rid of because it's more to magnesium's advantage to lose those 2 electrons. And if magnesium is going to combine with chlorine, there needs to be 2 chlorines because each chlorine only needs 1 valence electron. 2 negatives offset 2 positives. We are electrically neutral. And this happens through ionic bonding, where essentially, for the most part, these 2 valence electrons of magnesium leave the orbit of magnesium, not completely, but chlorine very much dominates the attraction of the electrons in what they would call the electron cloud density, the fancy term for it. So argon basically takes on that 6 electron of magnesium's, whereas magnesium loses these 2 valence electrons, mimics neon, to chlorine mimicking argon. The other type of ways that we can reach octets in bonding is covalently. This tends to be with nonmetals, and this implies a sharing of electrons in a pair. So nitrogen starts off as 1s2, 2s2, 2p3. And so nitrogen, being in the same group with phosphorus and arsenic, needs 3 more covalent bonds. So what happens is, if nitrogen is going to occur in nature, it partners up. It's a diatomic element, much like oxygen, hydrogen, chlorine, fluorine, iodine, and bromine. So so they do not occur unpaired in nature. They occur in pairs. In this case, they form triple bonds. As you could, let's try to differentiate between the 2 atoms. I will assign this atom's electrons as black and this one as red. So you can see each one has only 5 electrons. So how are we going to get an octet? Well, by sharing 3 of one with 3 of the other, we get 2, 4, 6, 8. We get an octet, 2, 4, 6, 8. This nitrogen atom gets an octet. Over here with water, of course, which is polar covalent because we have a significant electronegativity difference. They're still sharing. What happens here is the electropositive hydrogens each have 1 electron to give. Oxygen, being in group 16, needing 2 covalent bonds, will share its 5th and 6 electrons with each of these hydrogens. 2, 4, 6, 8. Oxygen has an octet. Remember, hydrogen is an exception to about everything. Hydrogen only needs 1 covalent bond, so it can mimic the noble gas helium. And in closing, I wanted us to take a look at one interesting way of having covalent bonding, and this is the coordinate covalent bond. Probably the most well-known textbook example is carbon monoxide, which we never want to breathe in, very toxic to us. Carbon, of course, has 4 electrons to share, whereas oxygen has 6. Probably need to represent the 3rd and 4th electrons this way as red. And what oxygen does is oxygen actually donates both the electrons in one of its bonds. And this is represented with an arrow often in these types of Lewis diagrams, where the arrow is pointing toward the beneficiary of the 2 electrons that the other is ponying up, so to speak. And you can still see 2, 3, 4, 5, 6 electrons of oxygen are represented, and I've color coordinated to show you how the 4 of carbons are represented. But we aren't inventing more electrons than they have or taking away. Carbon has 4 electrons on his outer valence shell. Oxygen has 6. We're not adding or taking away. We see 4 and 6 here, but there's a little bit of creativity that is happening to make this octet work. This is called, once again, a coordinate covalent bond. Later on, we'll be talking about a couple of other exceptions to the general octet rule in bonding from a Lewis diagram perspective, and what are called expanded octets. We'll get into that probably early next week.